Down here at the bottom of page 3 for section 9.2, same type of idea here. We're going to simplify, multiply, and if possible simplify. Some of these won't require multiplication. You'll start, like number 98, it'll start right here. What's different, it really should say what's different on both of these. So we'll just write that in. What's different as you look at all three of these as you go through is that you've got different roots. It's no longer just plain old square root. You've got fourth root, third root, fifth root, fifth root. You can call this cube root if you want, but after square and cube, you just say it by the number fourth, fifth, fifth. But it's not going to change what we do. We can still multiply, mush things together, pull them apart. We can still break apart the radicals across a fraction because that's really division. We're just going to now be looking for, in terms of numbers, a fourth root, something that multiplies by itself 4 times to get you back to that number. In terms of variables, once they come along, right now we're just dealing with numbers. In terms of a cube root, what multiplies by itself times 3. And here's where you want to remember from 9.1, page 554 had that little study tip box of cubes, fourth roots, and fifth roots that were, you should become fairly familiar with it so that you can recognize these numbers and not spend a lot of time searching for the cubes and the fourth roots and the fifth roots. Okay, so what do we do here with fourth root of 48? Well, first of all, since it's just a number, what you're looking for is, something times itself. Fourth root means that something times itself 4 times to get back to your answer, okay? Where all these would exactly match. But no such thing exists to get 48. 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81. So there's no nice number that you're going to get, be able to say is the fourth root of 48. However, you can get there one of 2 ways. You can do a simplification. You can find something that's simplified inside of it. So if you have taken the hint of looking at page 554 and kind of getting familiar, then you'd realize, oh, well, let's try 16. 1 doesn't get us anywhere, but 2 to the 4th is 16. Let's see if this breaks out. In fact, 48 is 16 times 3. So you could say that this can be written as the fourth root of 16 times 3. That can break apart, fourth root of 16, fourth root of 3. The fourth root of 16 we know to be 2. And then we're just left with the 3 inside that fourth root. Notice that we bring that index all the way down, and that would be our final simplified version. But that's not the only way to get there. Let's say you kind of blank, didn't really study the things. You could take the time. Now notice it does take extra time to do this. But you could break 48 down completely to its prime factors and see if any one factor shows up 4 times, and that would give you something that you could pull out. So 48, well, let's just start breaking it down. 4 times 12, are those done? Nope, 4 can go further. 2 times 2, those are done. 12 can go further. Let's go 3 times 4. 3's done, but 4 can go one more time, 2 times 2. And that's your prime factorization of 48. And notice, here's 2 4 times. 48 is 2 to the 4th times 3. There's what you can take. Notice there's our 2. We took the fourth root of it, so 2 comes out, and then 3 stayed under the radical because you can't take the fourth root of 3 without making it a really ugly number. So we want to keep these as nice whole numbers here. So 2 fourth root of 3 is our final simplified version. Looking at number 108, now we're doing the cube root, and we've got a division. So again, we can use the quotient rule and say, great, I can split that. I haven't changed anything here. The reason why I want to split is because 5 divided by 27 on the inside doesn't get us anything simpler. Up top, you remember we did 60 divided by 5 to get 12, so that we could work our way to something simpler. But down here, we're going to split this because we recognize that the cube root of 27 is a number that we know. It's 3. because 27 is 9 times 3. 3's done. The 9 goes further. 3 times 3. There, the 3 shows up 3 times. That means that's a cube root of it, and that's all there is. So this just becomes 3. Cube root of 27 is 3, meaning 3 times 3 times 3 gives you 27. But cube root of 5 doesn't go anywhere, so that's the final version of that answer. Again, try not to make these harder than they need to be. Just kind of work yourself through. We're still at the beginning of chapter 9. We haven't thrown in a lot of variables yet, but we'll get there. But here's one for you to try. We're in fifth roots now, down here at number 104. And you're starting with them separated, but it is multiplication, so you can go ahead and do what with it? I'll let you try that one and pause the video, and then we'll come back to check your answer. So I left you with the question, what can you do with this with multiplication? Well, you can mush this back together. I know that's not technical terms, that's pretty street for mathematics, but you can make this one big root 5, 16 times 4, and you'll end up with 64, and then discovering if you have any perfect fifth roots in there, and you actually do, 2 to the 5th is 32. So you end up being able to pull a 2 out, and it leaves behind a 2 on the inside. Okay, 2 fifth root of 2. And if you weren't able to follow that one or get it on your own, please bring it to class. I'm happy to do it with you. That will make class time really usable for you if you bring your questions, and we'll take care of you. And no question too small or too big. We will help you understand. Okay, we'll see you there.